few more words about the compiler, a high-level programming language compiler, and the difference between compiler and assembler. So, compiler is a program that translates a high-level programming language source code into a set of instructions which correspond to a specific instruction set architecture. And after that, the program can then be linked into an executable image, loaded into memory, and executed. So this demonstrates an example of a compiler, which is GCC compiler. It's an open source compiler that is available on Unix and Linux systems. And an example of a command line where a set of input files are processed by the compiler. So the command gets into the compiler. This is a program in computer memory. The source code typically has file extension .c. It then executes a preprocessor which deals with preprocessor directives such as includes and defines, and converts it into pure source code of the C programming language. Then compiler processes the input, the source files, and generates a set of assembly instructions written in a source file. That source file is then processed by GAS, which is open source assembler program, and then the linker is invoked, and the linker assembles individual modules resulting from multiple source files and libraries, and generates a program that then can be run on this specific platform. And then the compiler, which kind of makes invocations of all of these stages, then stops and goes back to the prompt so that you can execute your next shell command to run this process again. So compilers for various programming languages would exist on every platform, and you can have multiple compilers dealing with the same programming language input but generating various versions of executable files. So this is all specific to your CPU, and therefore on every platform you have to install a compiler that is suitable to run on the architecture that you have and the operating system that you're running. Assembly language, on the other hand, is a program that translates mnemonics of CPU instructions into an object file that can be also linked together to produce the executable file. However, that input that assembler is reading and processing is already specific to your platform. So if the source code of a C or C++ program is portable and independent of your current platform, assembly code is specific to your architecture and your platform. Next concept is called microarchitecture, and microarchitecture in essence is a set of wired logical circuits inside the CPU. And this microarchitecture is a layer which is sitting right next to the compiled program, because it's the one that does the translation of each instruction into an actual steps that CPU is making on behalf of each instruction. So microarchitecture is unique and specific to each model of the CPU. The microarchitecture itself is a combination of very simple, well-recognizable logic circuits. These logic circuits we will see when we're modeling logical circuitry in our course, but particular implementation is just a number of trade-offs between the performance and cost. So you can add more hardware to increase the performance, but at the same time the cost will be higher, and vice versa. And digital logic circuits or logic devices are made up of individual transistors and gates that are combined from these transistors. And again, that's something that we're going to practice with in our course.